Hello, welcome to Manifest Maths. Today we're going to look at polynomials and polynomial functions. We want to be able to factorize polynomials just like we can with quadratics and use what's called the factor theorem. It's an important theorem that we can use and apply when factorizing cubics and even quartic equations. By the end of this video we'll come back to these two questions, both taken from recent WJC papers. You can see that they're quite different, but they require the same skills and implementing the same techniques, both questions. Okay, so let's have a look at what is meant by the factor theorem. So the factor theorem is used if we have a function, say y equals f of x, and we want to decide if we have any factors of such a thing. Now, if you do have that function y equals f of x, then if we substitute some number in, let's call it a, and find f of a, and that gives us the value of 0, that implies that we can deduce that x minus a is a factor of the original function. Also, if we have a fraction, b over a equal to 0, when we substitute it in, that implies that our factor this time will be of a different form. It might look like ax minus b. And that will be a factor of f of x as well. So this is quite easy to prove. So let's say, for example, we have a function y equals f of x, which is equal to, let's keep it as a quadratic for now, x squared plus x minus 6. Now, if I wanted to find a factor of this quadratic function, what I could do is substitute values for x in and see if I can make 0. I've made this one easy. So, for example, if you find f of 2, you end up with 2 squared plus 2 minus 6, which gives us 4 plus 2 minus 6, which obviously equals 0. So what that means is, for this function, x minus 2 is a factor. Now, we could keep on trying other numbers to find the other factor, or what we could do in this case is factorize, because that would be your first instinct, I would imagine. If you were to factorize this function, it would be a double bracket with an x in the front. You'd look for two numbers of times together to give you minus 6, which add together to give you 1, and you would have deduced that it was minus 2 and 3, which gave you minus 2 and 3. Now what you'll notice is the factor that we discovered using the factor theorem was this one here. Okay, so the first step very often for questions involving polynomials is to use the factor theorem. Okay, so we're going to look now at how we might apply that. So you might want to pause the video and write this question down, but we're going to jump straight in with it. So our function, or f of x in this question, is equal to 12x cubed minus 29x squared plus 7x plus 6 equals 0. Now what I want you to do is I want you to substitute numbers into this function and see if you can obtain a value of 0. Hopefully you were able to have a play around with that. And you would have discovered, hopefully, that f of 2 gives 0. Let's prove that that is the case. So we'll have 12 times by 2 cubed minus 29 times by 2 squared plus 7 times by 2 plus 6. And then we can work this out. 12 times by 2 cubed, so that's 12 times by 8, which is 96, minus 29 times by 2 squared, which is 4, which will give us 116, plus 14, plus 6. And then we see that if we do this sum, we end up with an answer of 0. So what that means is x minus 2 is a factor. Now, we want to find when this function is equal to 0. So what we want to do is we want to try and obtain 3 brackets as a product equal to 0. So then we can use these three brackets to find where the roots are and when that's equal to 0. Now, the next step for this kind of question is called polynomial division. This is a technique that you must practice and to be proficient at. Now, we know that x minus 2 will go into this function here. So the first step is to see how many times it will go into that function. And this is when we do a bit of long division. So if we set up x minus 2 and then a long bus stop here, which gives us 12x cubed minus 29x squared plus 7x plus 6 underneath. What we do now is we execute the polynomial division. We always start off with this x here and the 12x squared. So we divide 12x cubed. We divide the 12x cubed by x, and that gives us a value of 12x squared. Now, if you want to check if that's true, if you times 12x squared by x, you get 12x cubed. Next step now is to multiply this value that we just had on the top by the x, which gives us 12x cubed. And then we multiply it by the minus 2, which gives us minus 24x squared. And just like if we were doing division with numbers, what we would do now is we would subtract these two to find the remainder. Minus 29 minus 24x becomes minus 29 plus 24x, which gives us a value of minus 5x squared. Now, once you've done that subtraction, you start the process again. What do you times x by to get minus 5x squared, or what is minus 5x squared divided by x? That gives us a value of minus 5x. Then at this step, just like we did with the 12x squared and the x and 2, we multiply this minus 5x squared by both of these parts. Minus 5x times by x gives us minus 5x squared. Minus 5x times by minus 2 gives us plus 10x. Now, before we do the next subtraction, we must lower this 7x down. So you have plus 7x. And now we subtract. Minus 5x squared minus 5x squared, they will cancel out. 7x minus 10x gives us minus 3x. And then we start the process again. What do I times x by to get minus 3x? Well, that's going to be minus 3. Multiply the minus 3 by x, which gives us minus 3x. Minus 3 times by minus 2 gives us plus 6. Then when we lower this plus 6 down, we find that when we do our final subtraction, we end up with 0 at the bottom. So we've just proven that it goes into it with no remainder. Now the next step is to look at the quadratic that we had at the top, 12x squared minus 5x minus 3, and then is to factorize this expression, just like you would with quadratics as normal. Now we will multiply the 12 by the minus 3, which gives us minus 36. We're going to find factor pairs of minus 36, which add together to give you the minus 5, which is going to be minus 4, minus 9, and plus 4. Then we can write 12x minus 9, 12x plus 4, and then simplify both these brackets with a common factor. 3 goes into both of these, so we end up with 4x minus 3, and then 4 goes into both of these, which is 3x plus 1. So what we've done now is we've factorized the quadratic as well. Now, we initially discovered that x minus 2 was a factor, and now we've discovered the other two factors. Okay? Now, what that means is x minus 2 times by 4x minus 3 times by 3x plus 1. That represents our original function. And we want to put that equal to 0 and solve these equations. Now, just like when solving quadratic equations, what that implies is that because these are all products, then any one of these brackets could be equal to 0 to make this product equal to 0. So our solutions, x minus 2 could be equal to 0, in which case x is equal to 2. We've proven that one anyway up here. Or 4x minus 3 could be equal to 0, in which case x is equal to 3 over 4. So our second solution is x is 3/4. Sorry, it's a 3. And then the final one, 3x plus 1 equals 0, in which case x equals minus 1/3. And those are our three solutions. Now, what you could do, finally, is you could plot those roots on a graph for x and y, and it gives you a good indication of what the cubic will look like. So one of the roots was where x is 2, and the other one was where it was equal to 3 over 4, and the other one was where it is equal to minus 1/3. We know that the intercept is 6, because it's on its own here. So we can estimate that the cubic will do something like this. And again, that's a very approximate diagram. Okay? Right. If you pause the video now and try this question for yourself, use the same method, find the factor first, then execute the polynomial division for yourself. So hopefully you had some success with finding the factor for this one. In this case, it ended up being a negative number, which is f is minus 2. Let's just show why. So 6 times by 2 minus 2 cubed plus 13 times by minus 2 squared minus 10 times by minus 2 minus 24. So minus 2 cubed is minus 8, and 6 times by minus 8 is minus 48. 13 times by minus 2 squared is 4, positive 4, and 13 times by 4 is 52. Minus 10 times by minus 2 is plus 20, and then minus 24. And we can see that this will give us 4 plus 20 minus 24, which gives us 0. So what that means is, therefore, this time x plus 2 is a factor. So we know that x plus 2 goes into this cubic. So what we're going to do now is do our polynomial division. Set up our x plus 2 into 6x cubed plus 13x squared minus 10x minus 24, and then do the calculation. What times x by to get 6x cubed? So that's going to be 6x squared times the 6x squared by both of these parts, which gives us 6x cubed and plus 12x squared. Then subtract, they will cancel. 13x squared take away 12x squared gives us 1x squared. 1x squared. What times the x by to get 1x squared? That's going to be plus 1x. Then multiply this by both of these. X times by x gives us 1x squared. X times by 2 is plus 2x. Lower the minus 10x down, and then subtract. They will cancel. Minus 10x plus 2x is minus 8x. Then we divide. What times x by to get minus 8x? That's going to be minus 8. Multiply the minus 8 by x plus 2. And I've discovered that I've made a mistake somewhere. My apologies, there's a mistake here. Minus 10x minus 2x gives us minus 12x. That's a minus 12x. So x goes into minus 12x minus 12 times. And minus 12 times by x is minus 12x. Minus 12 times by plus 2 is minus 24. Lower the minus 24 down. And then subtract, and we get 0. So what we've discovered now is that 6x squared plus x minus 12 is also a factor. And the next step is to factorize this expression. Multiply the 6 by the minus 12, which gives you minus 72. Factor pairs of minus 72, which added together to give us 1. So that's going to be 9 and minus 8. Write out 6x plus 9, 6x minus 8. Simplify both brackets. 3 goes into both of these, so it's 2x plus 3. And 2 goes into this, so that's 3x minus 4. So these are our other two factors. So our final expression can be written as x plus 2 times by 2x plus 3 times by 3x minus 4 is equal to 0. So x plus 2 equals 0, in which case x is minus 2. 2x plus 3 equals 0, in which case x equals minus 3 over 2. And 3x minus 4 equals 0, in which case 3x equals 4 and x equals 4 over 3. And these are our three solutions. Okay, so 4 questions for you to try. Pause the video, give yourself a good 10-15 minutes on each of these, and then you can check the solutions in the next few slides. So with this first one, if you find f of minus 1, that gives you 8 times by minus 1 cubed, which is minus 1, minus 2 times by minus 1 squared, which is 1, minus 7 times by minus 1, plus 3. That gives you minus 8, minus 2, plus 7, plus 3. These make minus 10, these make 10, so that's equal to 0. So therefore x plus 1 is our factor. Then we do our division. X plus 1 into 8x cubed minus 2x squared minus 7x plus 3. X goes into 8x cubed, 8x squared times 8x squared by the x, 8x cubed times 8x squared by 1, which is plus 8x squared. And we subtract minus 2 minus 8x squared gives us minus 10x squared. Then we divide. What minus 10x squared divided by x gives us minus 10x times the minus 10x by both of these parts, which gives us minus 10x squared. Minus 10x times by plus 1 is minus 10x. Sorry about that. Lower the minus 7x down, and then we subtract. Minus 7 minus minus 10 gives us minus 7 plus 10, which gives us 3x. X goes into 3x 3 times. Times the 3 by the x, which gives us 3x. Times the 3 by the plus 1, which gives us plus 3. Lower this 3 down and subtract, we end up with 0. So our quadratic was 8x squared minus 10x plus 3. Do the 8 times by 3, which gives us 24. Factor pairs of 24, which make minus 10, which is going to be minus 12 and plus 2. 8x minus 12, 8x plus 2. Simplify both. 4 goes into both. So 2x minus 3. 2 goes into both. 4x plus 1. So our 3 brackets are 2x minus 1, 4x plus 1, and x plus 1, the original one we found, giving us the answers of x equals a half for this bracket, x equals minus a quarter for this bracket, and then x equals minus 1. So these are 3 solutions. Now you could check by substituting these into the original function, but you will end up with 0. Right, next question. Okay, so with this one, we need to find our value of a, which will allow us to factorize initially. It ends up being f of 2. Now obviously you need to try different numbers until you get one that works. 6 times by 2 cubed, 6 times by 8. 2 squared is 4, and 19 times by 4 is 76, plus 22, plus 6. So we end up with 48 minus 76 plus 22 plus 6 equals 0. So we know that x minus 2 is a factor. Next we divide. Got 6x cubed minus 19x squared. That's 11x plus 6. X goes into 6x cubed 6x squared times. Times 6x squared by both parts here. Gives us 6x squared minus 12x squared. Sorry, that should be a cubed. Subtract. Minus 19 minus minus 12 gives us minus 19 plus 12, which is minus 7x squared. Divide. We end up with minus 7x. Times the minus 7x by both parts. Minus 7x squared. Minus 7 divided by minus 2 is plus 14x. Lower the 11x down. Subtract. 11x minus 14x is minus 3x. Minus 3x divided by x gives us minus 3. Times the minus 3 by both of these. Minus 3x. Minus 3 times by minus 2 is plus 6. Lower this plus 6 down. And then we have 0 at the end. Okay, so now we've got to factorize 6x squared minus 7x minus 3. 6 times by minus 3 is minus 18. So our factor pairs of minus 18, which add together to give us minus 7. It's going to be minus 2, minus 9 and 2. 6x minus 9. 6x plus 2. 3 goes into both. So we have 2x minus 3. 2 goes into both. 3x plus 1. So our three brackets are 2x minus 3. 3x plus 1. And our original one, x minus 2. Our three solutions are x equals 3 over 2. X equals minus 1/3. And x equals 2. Okay, next question. Find your original factor. In this case, it ends up being f of 2. Let's check it. 6 times by 2 cubed minus 13 times by 2 squared plus 4. 2 cubed is 8. 6 times by 8 is 48. 13 times by 2 squared. 2 squared is 4. 13 times by 4 is 52. Just minus 52 plus 4. That gives us 0. So our original factor is x minus 2. Now this question is slightly different to the previous ones when we come to divide. What you'll notice is there's no x term. It goes x cubed, x squared, then it mixes an x term. Now when you use this method for division, there still could be an x squared, an x term, or a number in the solution. So watch what we do here. We write down 6x cubed minus 13x squared, and then what we do is you put an imaginary 0x squared, 0x in, and a plus 4 at the end. Okay, so we've got 4 terms. Then you do the question as normal. X goes into 6x cubed times 6x squared. 6x squared times by x gives us 6x cubed. 6x squared times by minus 2 is minus 12x squared. We're going to subtract. They're going to cancel. Minus 13 minus 12 gives us minus 13 plus 12, which is minus 1x squared. X goes into minus 1x squared minus x times minus x by minus x, which is minus x squared, times minus x by minus 2 gives us plus 2x. And then this imaginary 0x that we put in needs to be lowered down. Then we're going to subtract. They're going to cancel. 0x minus 2x gives us minus 2x. X goes into minus 2x minus 2 times. Minus 2 times by x is minus 2x. Minus 2 times by minus 2 is plus 4. Then we lower our 4 down. Subtract to end up with 0. So our quadratic is 6x squared minus x minus 2. We're going to factorize this. 6 times by minus 2 gives us minus 12. Factor pairs of minus 12 which gives us minus 1. So this is going to be minus 4 and 3. So 6x minus 4 and 6x plus 3. 2 goes into both, so it's 3x minus 2. 3 goes into both, so it's 2x plus 1. So our three brackets are 3x minus 2, 2x plus 1, and x minus 2 equals 0. First solution, x equals minus 2 plus 2 over 3. Second solution, x equals minus a half. And the last one, x equals 2. And we've got our three solutions. Okay, next question. Okay, so this question is asking us to factorize. So that means obviously get it into the three brackets. It's not an equation, so it's not equal to 0, so we don't have to solve. You can see this worth less marks. If we find f of 2, that gives us 8 times by 8 plus 2 times by 4 minus 41 times by 2 plus 10, which is 64 plus 8 plus 10 and then minus 41 times by 2, which is 82. We can see that these three numbers come to 82, so that equals 0. So our factor is x minus 2. Next we're going to divide, so 2, sorry. We have 8x cubed plus 2x squared minus 41x plus 10. X goes into 8x cubed, 8x squared times, multiply, which gives us 8x cubed minus 16x squared. Subtract 2x squared minus 16x squared. 2x squared minus 16x squared is 2x squared plus 16x squared, which is plus 18x squared. Divide, that gives us plus 18x. 18x times by x is plus 18x squared. 18x times by minus 2 is minus 36x. I put it in the wrong place, should be here, minus 36x. Lower the 41x down, so minus 41x. Minus 41 minus 36x is minus 41 plus 36x, which gives us minus 5x. X goes into minus 5x minus 5 times. Minus 5 times by x is minus 5x. Lower the plus 10 down. Minus 5 times by minus 2 is plus 10. We have 0. So our quadratic is 8x squared plus 18x minus 5. Factorize. 8 times by minus 5 is minus 40. Factor phase of minus 40, which I had to give it 18. It's going to be 20 and minus 2. So we have 8x minus 20 and 8x minus 2. So it's plus 20. 4 goes into both of these. So we have 2x plus 5. 2 goes in both of these. So it's 4x minus 1. So our three brackets are 2x plus 5. 4x minus 1. And our original one, which is x minus 2. And we've factorized. No need to solve because it just wants us to factorize. So that job is done. Okay, so we're going to look now at another type of question, all right? We're going to go through this one, and then you're going to try one for yourself, okay? Because sometimes they like to give you what the factor is and then leave an unknown in the polynomial for you to solve, okay? So with this first one, the statement tells you that x minus 2 is a factor. So what you should understand now then, therefore, is that f of 2 will be equal to 0. So for part A, you need to solve for k by substituting x is 2 into the function. So we'll have k times by 2 cubed plus 2 times by 2 squared minus 41 times by 2 plus 10. We put that equal to 0. So this will give us 8k plus 2 times 2 squared, which is plus 8, minus 82 plus 10 equals 0. 8 plus 10 gives us 18, so 8k plus 18 minus 82 equals 0. That gives us 8k minus 64 equals 0. So 8k equals 64 and k equals 8. We won't do part B because it's the previous question that we just did. Okay, one for you to try then. So again, we've done part B here before. So if you have a look at part A and try it for yourself. So x minus 3 is a factor. So that means that f of 3 is equal to 0. So for part A, we've got p times by 3 cubed minus 13 times by 3 squared minus 19 times by 3 plus 12 would be equal to 0. So this would be 27p, 3 squared is 9, times by minus 12 minus 108. 3 times by 19 is minus 57. And we've got plus 12 at the end. oh, just notice a mistake. That should be minus 13 there, which gives you minus 117 here. Sorry, it's a mistake. Solve this equation. Minus 117 minus 57 plus 12. That gives us minus 162. And then 27p equals 162. So p equals 162 divided by 27, which is 6. Which is what it's asked us to show here. Okay. Right then, so let's go back to the two original questions. Let's have a look at the first one. Okay. Given that x minus 2 and x plus 2 are factors of the following polynomial, find the values of p and q. This question looks slightly different again. What you'll notice with this question is we've got to use the factor theorem twice. So if x minus 2 is a factor, then f of 2 equals 0. And if x plus 2 is a factor, then f of minus 2 will be equal to 0. So you substitute both of these into the function, and we're going to solve simultaneous equations. So the first one, when f of 2, that gives us 2 times by 2 cubed plus p times by 2 squared plus q times by 2 minus 12 equals 0. 2 cubed is 8 times by 2 is 16 plus 4p plus 2q minus 12 equals 0. 16 minus 12 is 4, so 4p plus 2q plus 4 equals 0. So our first simultaneous equation will be 4p plus 2q equals minus 4. Let's write that up here because we're going to have to use that after. When f of x is minus 2, we substitute in, so it'll be 2 times by minus 2 cubed plus p times by minus 2 squared plus q times by minus 2 minus 12 equals 0. And this will be minus 16. Minus 2 squared is 4, so it's still 4p. Q times by minus 2 is minus 2q. And we have minus 12 at the end. Equals 0. Minus 16 and minus 12 gives us minus 28. So 4p minus 2q minus 28 equals 0. So our second equation will be 4p minus 2q equals 28. And now we can factorize, solve these simultaneous equations. We've got our p's the same, so we can subtract it away. So 2q minus 2q is 2q plus 2q, which is 4q. Minus 4 minus 28 gives us minus 32. Let me just double check that, sorry. So 2q minus 2q minus 2q is 4q. Minus 4 minus 28 is minus 32. So q is equal to minus 32 divided by 4, which is minus 8. Use the original equation to work out p. So 4p plus 2 times by minus 8 equals minus 4. So 4p minus 16 equals minus 4. So 4p equals minus 4 plus 16, which is 12. So p equals 3. So that means that our polynomial is the following. 2x cubed. Our p was 3, so plus 3x squared. Our q is minus 8, minus 8x minus 12. Now to find the other factor, you could apply the factor theorem on this. The problem is it might be a fractional value and we could be here for a while. So a preferential method might be to divide by one of these two. If we use the x plus 2, that might be easier. X goes into 2x squared cubed 2x squared times the 2x squared by both of these is 2x cubed 2x squared times by 2 is plus 4x squared. Subtract, that gives us minus x squared. X goes into minus x squared minus x times. Multiply by both, which gives us minus 2x here, and we lower the minus 8x down. Minus 8x minus 2x is minus 8x plus 2x, which is minus 6x. Divide, which gives us minus 6. And then multiply out, which gives us minus 12 and then minus 12, and we get 0. So our other quadratic was 2x squared minus x minus 6. Factorize this, which gives us minus 12. 2 times by minus 6 is minus 12. Factor space of minus 12, which gives us minus x, minus 1, is minus 4 and 3. So we have 2x minus 4 and 2x plus 3. This one, 2 will go into both, so we have x minus 2. Well, we knew that one already, that was this factor. And the other one can't be simplified, 2x plus 3. Okay, so the three brackets were x minus 2, x plus 2, and 2x plus 3. Those are the first two, and this was the last one. And just like we suspected, when we solve this one, 2x plus 3 equals 0. So x is equal to minus 3 over 2. You know, it was definitely worth doing this method because we'd be there for a while trying fractions to try and make this equal to 0. Okay, so the polynomial division was certainly the best method for doing that. Okay. And then the final question, the cubic polynomial f of x is given by the following, where a, b, c are constants. The graph f of x intersects the x-axis of the point to the coordinates minus 3 and so on. Find the coordinates of the point where the graph f of x intersects the y-axis. Okay, so this question is slightly different. If we were to sketch where these points would be for our roots, we'd have minus 3, 2.5, and 4. And we're trying to find our intercept. That's what the question's asking. Find the coordinates of the point where the graph intersects the y-axis. Now at the moment we don't know whether it's above or below. So we don't know if it does something like this or something like this. Okay. Now the key here is to find the three brackets which go with these three roots. The first one's easy. So if x equals minus 3 was one of the roots, then that means that x plus 3 was one of the factors. So it's reverse of the factor theorem. If x equals 2.5, now you better be better off writing as a fraction 5 over 2. Then what that means is 2x minus 5 is one of the brackets. And then if x equals 4 is a factor, then x minus 4. Well, sorry, if x minus equals 4 is a solution, then x minus 4 is one of the brackets. Now, this question would be the opposite of doing polynomial division, and you would multiply the three brackets together. Okay? I would multiply these two first. Okay? X times by x is x squared. X times by minus 4, minus 4x. 3 times by x is 3x. And 3 times by minus 4 is minus 12. We still got to multiply this by 2x minus 5. Simplify this first. We have x squared. Minus 4 plus 3 is minus x, minus 12. Times by 2x minus 5. We're going to multiply these two brackets now, so we're going to times this term by both of these, the middle term by both, and then the last term by both. X squared times by 2x is 2x squared. X squared times by minus 5 is minus 5x squared. Sorry, 2x times by 2x is 2x cubed. X squared times by minus 5 is minus 5x squared. Minus x times by 2x is minus 2x squared. and minus x times by minus 5 is plus 5x. Minus 12 times by 2x is minus 24x. And minus 12 times by minus 5 is plus 60. Now we could simplify this, certainly. We've got 1x cubed term, which is the 2x cubed. We knew that was the case because it was in the question. Let's collect the x squared together. So we've got minus 5x squared, minus 2x squared, minus 5x squared, minus 2x squared is minus 7x squared. So we've inadvertently worked out what a is, which is minus 7. 5x minus 24x gives us minus 19x. And then finally we've got plus 60 on its own. So this is what our f of x is equal to. We know when it's equal to 0, these are the three solutions. And the intercept is plus 60. So the graph is the original one I drew, which is this one. And it goes through plus 60. Okay, so I hope you found this video helpful. I know it's a bit of a long one, but this is certainly a skill you need to be able to do for your Unit 1 exam. If you need to go back over factorising quadratics before this, that might be a good idea to do so. Okay, I hope you found the video useful, and I'll catch you for the next Manifest Maths video.